Alright, the topic for this video is called domain and ranges. First we'll talk about the domain, and then we'll talk about the ranges. The domain is the set of input values that has an intelligent output value. For example, if you have g of x is equal to 3x minus 1. If you plug in 5, you can multiply 5 by 3 and you can take away 1. 5 is in the domain. If you can put in 7 and get back an answer, 3 times 7, 21, minus 1, 20. So 7 is in the domain. These are the inputs, and what comes out, like the 20, that's the output. Whatever you could put in for x, whatever you can put between the parentheses, that is called the domain. Actually, what you get out is called the range. In this problem, x can be anything. I can multiply any number by 3. You give me 0.3821421. I can multiply it by 3. I might suffer a little bit, but I can multiply it by 3, and then I can take away 1, and I'll get my answer. I can multiply any number by 3 and take away 1. That is, no matter what number I put in there, I get back a result. I get back some number, because I can multiply any number by 3, take away 1. Alright. So the answer is, and we'll do more formally in a little bit, the answer is the domain for g of x is all numbers. All real numbers. Now, on the other hand, if I give you that h of x is equal to the square root of 10 minus x. If I tell you x is 6, you'll tell me that h of 6 is equal to, and if you give me a number, then I will say 6 is in the domain. But I don't know that yet. Put a question mark there. 6 is in the domain? The answer is yes. 10 minus 6 is 4, and the square root of 4 is 2. h of 3. h of 3. 10 minus 3 is 7. You get back the square root of 7. We got back an intelligent answer. 3 is in our domain. If we don't get back an intelligent answer, then that x value is not in the domain. For example, here x was 3. What if I tell you x is 16? What if I tell you x is 16? What is h of 16 equal? Well, 10 minus 16 is negative 6. The square root of negative 6 does not exist. DNE does not exist. This is not a real number. You can't take the square root of a negative number. Can't take the square root of a negative number. For example, the square root of 16 is equal to 4 because 4 times 4 is 16. Now, when it comes to the square root of negative 6, you can't even give me the sign of the answer, because there's 3 different types of numbers. Positive numbers, the number 0, and a negative number. Remember, if we take the answer and multiply it by itself, we should get back 16. The problem is, or in our case, negative 6. If the answer is positive something, well, when you square a positive number, you get a positive number. I don't know what the number is, but no positive number is negative 6. When you square, can the square root of negative 6 equal 0? Of course not. 0 squared is 0. That doesn't equal negative 6. So maybe the square root of negative 6 can be some negative number. No, it can't be. Because when you square a negative number, you get back a positive number. And no positive number is ever negative 6. Negative 6 is not a positive number. So 16, remember, I plugged in 16. 16 did not, I let x be 16, but I didn't get back a y value. I got back nonsense. I got back something that doesn't exist. That means 16 is not in the domain. Only values that you can plug in for x and get back intelligent answers. The numbers that you plug in for x, not the intelligent answers, are numbers in the domain. 16 is not in their domain. And no more question for the first one. 6 is in the domain. 3 is in the domain. 16 is not in the domain. The domain are the set of input values that give back an intelligent output. For example, you input numbers and you get back outputs. Usually the input numbers are called x and the output numbers are called y. But that's a whole nother story. They don't need to be called x and y. You can call them A and B. You can use Greek letters. Doesn't matter. So maybe formally we'll write down the definition for domain. The domain is their set of all input values that give back an intelligent output value. You can put in any value as an input value, but you may not get back an intelligent output. Only the input values that make sense, let's start over. Only the input value that give you back outputs that make sense, those inputs the inputs that give you back intelligent outputs, those input values make up the domain. Whatever you can put in here and get back an intelligent answer, that's the domain. Now, like I said, usually input are x values and output are y values. X and y. X is before y. And this is how I remember. Domain and range. Domain and range. D comes before R. D talks about the x values because x comes before y. The earlier letters pair up and the later letters pair up. D goes along with x, which is the input, and R goes with y, which is the output. I just realized something as well. I is before O, and D is before R. You can say D goes with the input, and R goes with the output. The domain are the input values, the x values usually. And the range, when we talk about it, is the y values. Alright, so now we looked at some examples and we picked some isolated numbers to see if they were in the domain. And we found some that were in the domain and some that were not in the domain. But now I need to give you a more formal way of deciding what's in the domain. There's only two problems. Okay, let's just look at this. Suppose I tell you g of x is 3 over x minus 5. Now, you can divide 3 by any number. You can divide 3 by 2, you get 3 over 2. You can divide 3 by 1, and you get 3. Trust me on this. Well, you can divide 3 by a half. Trust me, you get 6 back. After all, half times 6, or half or 6, is 3. You can divide 3 by negative 8. Top is positive, understood. The bottom is given to be negative. Positive over negative is negative. 3 over 8. Final answers should not have a negative on the bottom. The only thing you can't divide 3 by is 0. This is undefined. Why is it undefined? Because 0 times any number I put there will equal 0. Hence, 0 times any number I put there will not equal 3. It's not defined. You can't come up with any number. You can't say, oh, this is 3. Nonsense. 0 times 3 is not 3. 1 times 3 is 3. 0 times 3 is not. You can't put 31. 0 times 31 is not 3. 0 times 31 is 0. You can't put negative 3. Forget the 1 there. Negative 3. 0 times negative 3 is not 3. 0 times negative 31 is not 3. It's not defined. You can't divide by 0. That's one problem. You can't divide by 0. You can divide 3 by any number you want except 0. Okay, you can't divide by 0. So, x can't be 0. The domain is all numbers but 0. This is not true. Because if x is 0, you know what? We're not dividing 3 by 0. 0 minus 5 is not 0. It's negative 5, which is negative 3/5. Since I got back an intelligent answer, 0 is in the domain. Like I said, we can't divide by 0. We're not dividing by x. That does not say 3 divided by x. It says 3 divided by x minus 5. Okay, define the domain. D for the domain. The denominator cannot be 0. Add 5 to both sides. 0 plus 5 is 5. X take away 5. Add back the 5. You just get x. X cannot be 5. That is your final answer. The domain is all numbers but 5. After all, if x is not 5, the bottom won't be 0. You can divide 3 by any number you want, except 0. Take your calculator. Do 0 divided by negative 0.321 or 132134. You will get an answer. Take 3 and divide it by the square root of 17. You will get an answer. Take 3 divided by negative the square root of 17. You'll get an answer. Convince yourself of this. You can divide 3 by any number in the world you like, except 0. When is this bottom 0? When x is 5. Oops, can't let x be 5. That is why the answer to finding the domain is x can't be 5. Since x just can't be one number or sometimes two numbers, we say when we define the domain, we say what x cannot be, rather than saying what x can be. X cannot be 5, done. The next type, so you only run into 2 different types of problems. The next type of problem is square roots. What's underneath the square root sign has to be 0 or more. It can't be negative. For example, if you're told that h of x is the square root of x minus or x plus 3, what's underneath the square root sign? Now there are 3 types of numbers. You can take the square root of 0 and it's 0. You can take the square root of positive numbers, but you can't take the square root of negative numbers. So what's underneath the square root sign, it can be greater than 0 for positive, and it can even equal 0. Okay? Whatever on the denominator must be 0 or more. Can't be less than 0. I mean, let's be honest. If x plus 3 was less than 0, was negative 8, then this would be negative 8. I'm telling you what this symbol says. These two small little lines have many meanings. It tells you whenever you see x minus 3, you have every right to say, I may have said that wrong. Those two lines say wherever you see x plus 3, you have every right to say negative 8. So I'm going to say negative 8. The square root of negative 8, can't take square root of negative numbers. So the first statement you can say for the domain is already there. What's underneath the square root sign must be greater than or equal to 0. Solve for x. Take away 3 from both sides. 0 minus 3 is not 3. I know that isn't true because 6 minus 3 is 3. 0 minus 3 is not 3. Okay, and 3 minus 3 is 0, so you're just left with x. The domain is x's have to be greater than or equal to negative 3. Think of a number that's not greater than or equal to negative 3. I like to say where 0 is. Here's negative 3. What number is not greater than negative 3? Well, you know what? Negative 4.5 is not greater than negative 3. H of 4, negative 4.5. Well, you take what's in the brackets and you add 3. Then you take the square root of that. Negative 4.5 plus 3 is negative 1.5. You can take the square root of a negative number. So it is working. The domain is all numbers that are negative 3 or above. So there are two things. The denominator can't be 0, and what's under the square root sign must be greater than or equal to 0. When somebody asks you domain, you think what's underneath the square root sign has to be greater than or equal to 0, and the denominator can't be 0. So, if I give you, now this one is, in some ways, it's the easiest one, and in other ways, understandably, it's the hardest one. So you have 4x minus 2. Well, you know, let's not do this one yet. Suppose you have this. Suppose you have this. Okay. There are two steps. Step 1, step 2, and then the third step is to put it together. What's in the denominator cannot equal 0. Add 7. 0 plus 7 is 7. The left side is x. X, not 0. Excuse me, not 7. X cannot be 7. Okay, not a problem. This is AND. Condition 1 and condition 2 have to be satisfied. You can't just have positives you can't just have greater than or 0 in the denominator, under the radical, but you can have 0 in the denominator. No. You can say, oh, I don't have 0 in the bottom, so I can have anything under the radical sign. No. What's under the radical sign has to be greater than or equal to 0, and the denominator can't be 0. Okay, so what's underneath the square root sign has to be greater than or equal to 0. Add 2 to both sides. Then you have 4x must be greater than or equal to 2. Divide by 2, divide by 4, so the 4's cancel, and you get x. greater than or equal to 2 over 4 is a half. Okay? So x cannot be 7, and x must be greater than or equal to a half. Now, you know what? For the first time, I just want to change something. I'm sorry. Let the bottom be x plus 7. I knew this was wrong. I'm sorry. Let the bottom be x plus 7. So we should take away 7 from both sides. And the 7's cancel out on the left, and 0 minus 7 is minus 7. So x cannot be negative 7, and x must be bigger than a half. Now, for and, both statements must be true. If you must be bigger than a half, if you must be a half or bigger, then doesn't this already say you can't be negative 7? That is, isn't this redundant? For and, this statement must be true. So does the first one. But if x is a half or more, here's 0, here's negative 7 and negative 6, etc. And here's a half. You can be a half, so it's closed in, or you can be more. Well, you can't be 7 then. If you have to be a half or more, then you can't be negative 7. This is redundant. I mean, might as well say you also can't be negative 4.5. If you have to be a half or more, you can't be negative 4.5. Okay. So what I'm saying is we need to clean up our answer. We need to clean up our answer. We need to say that the final answer is, the domain is, x has to be greater than or equal to a half. Okay, if you're already greater than a half, you don't have to worry about saying you can't be negative 7. Alright, you need to think about this possibly for hours and hours. Suppose you have that f of x is equal to x minus 10, and you have underneath the square root sign x minus 2. Okay, so what's in the denominator cannot equal 0. Add 10 to both sides. 10's cancel out on the left side. You just get x. 0 plus 10 is 10. X cannot be 10. After all, 10 minus 10 is 0. I mean, you can just see that. 10 minus 10 is 0. X can't be 10. You want to work it out? Fine. But just like you should know, when somebody asks you to add these two numbers, you don't show why you put a 5 there. You don't show that 7 plus 8 is 15. You don't show why you're carrying a 1. You just do it. Well, at this point in your life, and the sad thing is most teachers don't want you to think at all. But at this point in your life, you should know 10 minus 10 is 0. Okay, x is 10. Just say it. I mean, step 1. X can be 10. Why? Because the bottom will be 0. Alright. Now, step 2 is what's underneath the square root sign? X minus 2. It has to be greater than or equal to 0. Plus 2 on both sides. This cancels out. X must be greater than or equal to 2. Okay, x can't be 10. And at the same time, it must be 2 or more. Let's graph the 2 or more. Like I said, I like to put 0. Here's 2. You can equal 2, and you can be more. But you know what? You can't be 10. Because for and, both of these statements have to be 2. Yes, must be true. Yes, 10 is greater than or equal to 2. But you know what? 10 does not equal 10 is not a true statement. 10 does not equal 10? Of course 10 equals 10. So 10 does not equal 10 is false. 7 doesn't equal 10. 9.5 doesn't equal 10. Those are true. But 10 doesn't equal 10? That's not true. That is, we need to have both of these true at the same time. So we remove 10. We remove the number 10. And just for the record, that number, that is this number right here, that number is not 10. This number is not 10. This number is not 10. In fact, every number on the number line is not 10 except 10. All right. So what survived is this portion right here, these two pieces. This and that. That's what survived. There are two pieces. You have this piece and you have that piece. You have the union of those two pieces. The domain is, this is the symbol for in between. X can be in between 2 and 10. That's this piece. X can be in between 2 and 10. Since it's closed at 2, X can equal 2. Since it's open at 10, X can equal 10. Or, if you prefer, you can put the union symbol. Or, now we have the second piece. X is greater than 10. You know, there was no upper limit for me to put. All those numbers are greater than 10. They're not equal to 10, but they're greater than 10. You can say, or X is greater than the number 10. And that answer is finished. It's done. It's done. Now, sometimes you may have two denominators, and each one of them can't be 0. Sometimes you might have two square root signs. Each one of them has to be greater than or equal to 0. Suppose I told you that g of x is equal to the square root of x minus 10 minus or plus or divided by the square root of 15 minus x. Okay? There is no step 1. Why? Because we're dividing by 1, and 1 never equals 0. 1 never ever equals 0. Okay, so step 1, nothing to do. The denominator never equals 0. Put an exclamation mark. Let's work. Step 2, what's underneath? I guess I was a little bit sloppy. I should not say what's underneath the square root sign. I should say what's underneath the square root signs. And what's in the denominators can't be 0. There might be more than one denominator. What's underneath the square root signs have to be greater than or equal to 0. What's underneath the square root signs have to be greater than or equal to 0. At the same time, you can't say, oh, when x is 11, that's greater than 0. But when x is more than 10, less, excuse me a moment. Oh, okay. For example, here, x can be 25. 25 minus 10 is 15. Square root of 15 is okay. But x can't be 25 here. I mean, the whole thing has to make sense. You can't say the square root of 15 minus, I don't know, because I don't know the square root of a negative number, makes sense. They both have to make sense. Okay, so at the same time, that means and, at the same time, x minus 10 must be greater than 0, and 15 minus x must be greater than the 0. You add 10 to both sides. The 0 plus 10 is 10. On the left side, you just get x. X must be 10 or more. You take away 15 from both sides, maybe. You get negative x, because this cancels out, but that is negative x, is greater than or equal to negative 15. But that doesn't say x, it says negative x, and we want it to say x. Now remember, negative x is the same as negative 1x. So you divide by negative 1 to get x. You divide by negative 1 to get x. The thing is, whenever you multiply or divide an inequality, those are inequalities are things that have inequality symbols. Doesn't have equality symbols. Doesn't have equal signs. Whenever you multiply or divide an inequality by a negative number, you change direction of the symbol. X must be less than or equal to 15. So we have that x must be greater than or equal to 10. I just copied it down. And x must be less than 15. So down here I'll put the final answer, but let's see what's going on. Here's 0. That's the 0. There's 0. There's 10. There's 15. X is equal to 10 or bigger. Here's equal to 10. Here's bigger. X is equal to 15 or less. For and, you have to look for overlapping. Above this line, I'm looking to see which vertical lines cross two lines. These are the lines I'm looking to cross. These are the lines I'm looking to cross. It seems like only in here, only between 10 and 15 do I have both lines above. Only here do I have both lines. Both lines are not for this x value, because when I look up, I only crossed one of them. But when I look up at 11, I cross both lines. When I look up at 12.8, I cross both lines. In fact, I even cross at the endpoints. The final answer, this is the symbol for in between learning. It makes life easier. X is in between 10 and 15. And in this case, we could include the endpoints. Okay, we could include the endpoints. Let me be clear why we can include the endpoints. I can be 10 or more. I can equal 10 or more. So the first line, it includes 10, and it even includes 15, among other numbers. The second line is 15 or less. It includes 15 or less. It includes 15 or less. That means it includes 10. Both lines included 10 and 15, and every number in between. Okay, that's why in the bottom I put equal signs for 10 and 15. If you have more than one square root sign, they both have to be, you can only pick x's that make both square root signs 0 or more. If you have 2 denominators or 17 denominators, none of them can be 0. If you have the square root of x over x minus 2 pi. Okay. Now, remember, this is the same as square root of x over the square root of x minus 2 pi. So, we have actually 3 things to do. Step 1 says, what's in the denominator, that's in x, excuse me, what's in the denominator, namely the square root of x minus 2 pi, can't be 0. That's step 1. And step 2 says, what's underneath the square root signs have to be 0 or more. But I have 2 square roots. Underneath the first square root sign, it must be greater than or equal to 0. What's under the second square root sign? It must be greater than or equal to 0. And these 3 conditions have to be true at the exact same time. When is the square root of something not equal to 0? When is the square root of something equal to 0? Namely, if what you're taking the square root of is not 0. You take the square root of 7, you don't get 0. If you take the square root of negative 7, you don't get 0. You get undefined. That's not 0. So what's underneath the square root sign can't be 0. Because this is the denominator. What's in the denominator can't be 0. If it happens to involve the square root, then what's underneath the square root sign can't be 0. Add 2 pi to both sides. On the left it cancels. X cannot equal to 2 pi. And, well, this one's already solved for x. And x has to be greater than or equal to 0. Well, this is not redundant then. Because if you're bigger than 0, you can be 2 pi. And we have to say no. Okay, now I add 2 pi here. I add 2 pi. The right side, 0 plus 2 pi. The left side, I get x. And at the same time, x has to be greater than or equal to 2 pi. So, let's graph this. Top right-hand corner. Let's graph it. I like 0 and the other number that came up with 2 pi. Let's do this first. X can be 0 and above forever. X can equal 2 pi and above. The first one says x can't equal 2 pi. That means it can equal anything but 2 pi. Since there are 3 conditions, I want all numbers on this line that have 3 lines above them. This value, for example, it only has 2 lines above them. Let me not put all these circles. You'll think they mean don't include. But nonetheless, that line had only, that x value had 2 lines above them. At x equals 2, there's only 2 lines above them. This line, because this line here, and this line. The top line passes, doesn't include 2 pi. But you know what? Every number above 2 pi has all 3 lines above them, greater than 2 pi. The domain is you can take any number that's greater than 2 pi, and then this will make sense. And then this would make sense. You can take any x value bigger than 2 pi. All right, now let's see what we have here. Okay. Let us now talk about range. Imagine taking all the x values in the domain, all their allowable x values, and looking at what y values you get. Taking all the x values, allowable x values, and seeing what the y values are. Remember, y is another name for f of x. And suppose I say x squared plus 2. Or start off with a simpler one. How about just x plus 2? What are all the y values here? Well, if you think about it for a moment, it has a non-zero slope. The slope is 1. Only when the slope is 0 do you get a horizontal line. We have our slope. Maybe it looks like this, but it has some slope. Well, can you ever be that value? Can you ever be that y value? The answer is absolutely. Plug in that x value, and you'll get back that y value. Can you be this y value? Sure you can. Take that x value. Take that x value. Well, okay, you can be this value. And you get back this value. If you want to get back the value I just pointed to, take this x value. And f of that will give you back that y value. Can you get this y value? Sure you can. Absolutely. Just use that x. F of that x value gives you back, yep, that y value. Can you be this y value? Sure you can. Use this x value. You'll get back that y value. Lines that have non-zero slopes can take on any value. Any value. I can get this to be any value. How do I get x plus 2 to be any value? I mean, if I want it to be 15, I just take 2 less. Let x be 2 less. 13 plus 2 is 15. If I want to get it to be 151, I just let x be 2 less. If I want x plus 2 to be negative 11, I let x be 2 less. Negative 13. If I want it to be negative 111, I mean, I have a number x, and all I know is when I add 2 to it, I end up in negative 111. Well, that's negative 112. Let x be negative 113. Yeah, I can get it to be any number. I can get x plus 2 to be any number. The range is everything. And, okay, the range is everything. Now, I did say in the last domain that there was this one simple problem that is so simple that it might be very hard to do. I didn't mean to start range in that case, but let's just go back and look at that very simple problem. Suppose f of x is equal to 3x squared minus 4x plus 5. Well, step 1 says the denominator can't be 0. Well, you might be mathematically mature enough to realize the denominator is 1, so 1 is never 0. Okay, not a problem. What's underneath the square root sign has to be greater than or equal to 0. But that really means, remember, okay, if you're not greater than or equal to 0, if you're not greater than or equal to 0, that means you're less than 0. Okay, that is, what's underneath the square root sign can't be less than 0. But you know what? There's no square root sign. There's no x value in this world that will make what's underneath the square root sign negative. For one reason and one reason only. There is no square root sign. Okay? There is no square root sign. So what's underneath the square root sign will never be negative. It's not so much that we want what's underneath the square root sign to be 0 or more. We don't want it to be negative, which means we want it to be 0 or more. These two statements are the same. They're the same statement. If you're not greater than or equal to 0, then you're less than 0. And we don't want that. Okay? So being greater than or equal to 0 is the same as not being less than 0. Okay? So if you want what's underneath the square root sign to to be greater than or equal to 0, and that is what we want. That's equivalent to saying what's underneath the square root sign is not less than 0. It's not negative. Hey, what's underneath the square root sign is not negative. There is no square root sign. One last comment. If you wanted to say, of course there's a square root sign, fine. You can always multiply by 1, and the square root of 1 is 1. I multiplied by 1. What's underneath the square root sign is greater than or equal to 0. That is, there's no x value that makes the denominator 0, and there's no x value that makes what's underneath the square root sign negative. That is, the domain is all real numbers. All real numbers. Some instructors or textbooks would say the answer is negative infinity to positive infinity. Some books or teachers may say it's the symbol for all real numbers. Instead of writing all real numbers, there's a symbol for it. So if there are no square root signs and there are no denominators, or if from the very get-go the denominator was 43, then the denominator is never 0, and what's underneath the square root signs, again, an equivalent to saying it's greater than or equal to 0 is to say it's not negative. It's not less than 0. Well, if there is no square root signs, you'll never have negative underneath it. Okay, one last thing to say is you can square any number and multiply it by 3, any number. You can multiply any number by 4 and then subtract those results, and then you could add 5 to that. And whatever you get, you can divide it by 43. So, you can plug in any number. Alright. So, back to ranges. The range is all the y values that you could obtain. Now, ranges are much, much, much more tricky. Okay, remember, you have 3 types of numbers. Positive numbers, the number 0, or negative numbers. And if you square these numbers, if you square a positive, you get a positive. If you square 0, you get 0. If you square a negative, you get 0. So when you square a number, if these numbers underneath here are x's, then we squared x's. Okay? What we learned is given any value for x, we know that x squared, well, what do we know about x squared? We either get positive or 0. We get greater than 0, that's positive, or we get 0. If you square a number, the least you get is 0. You get 0 or more. The least you get is 0. Okay, so if f of x is equal to x squared, find the range for f. Well, what's the domain for f? Well, there's no denominator and there's no square root, so it's all numbers. A second check, I can multiply any number by itself. I can multiply negative numbers by itself, fractions by itself, 0 by itself, positive numbers by itself. The domain is anything. Now, what's the range? Well, I do know that when I square any number in the world, I'll either get 0 or positive. But the question is, can I get... Now, I can definitely get 0. F for 0 is 0 squared, which is 0. So 0's in the range. If you take what you get after you take f of a value, that's the value in the range. 0's in the range. F of 2 equals 4. 4 is in the range. So we can definitely get 0. Now, all I said is that x squared is 0 or more. I didn't say it can be that x squared can take on every value. Maybe, for example, the even numbers, 0, 2, 4, 6, 8, 10. These numbers go on forever. They're all greater than or equal to 0, but that's not all the numbers. Even if I add in the odd numbers, this certainly is not all the numbers. When you go shopping, not everything costs $0 or $1 or $2 or $3, etc. And even if you found a store that only charges $0, well, that's a good one, or $1 or $2 or $3 or $4, even if you found that store, they have to charge you sales tax. And then their total amount will not be $1 or $2 or $3 or $4 or $5. It'll be $5.38. Okay, there are many numbers other than 0, 1, 2, 3, 4. There's the square root of 17. There's the square root of 17.314. There's a lot of other numbers. Can we hit every one of them? Can we obtain every number that's positive? That is, let K be any positive number. Okay? Can we find F for something that gives you K? Okay? Can you find something that when you square it gives you K? Can you find something that when you square it gives you K? Okay? In fact, you should be able to find two answers. The answer is square root of K. The square root of K times the square root of K is K. That is, if K is 17, can I find F for something? Remember, F takes, I'm over here now, remember F takes what's in the brackets and it squares it. Can I take F for something to get 83? The answer is yes. You can take F of square root of 83. You can even take F of negative the square root of 83. Because F of the square root of 83 is equal to the square root of 83 squared. That is the square root of 83 times the square root of 83. And we get 83. No matter what K is, as long as it's greater than or equal to 0, I can take F of two values that give me K. That is, not only will F of X always be positive or 0, it can take on all positive numbers. Okay, like I said, this is deep stuff. Finding domains are not easy at all. Have to think, sometimes a lot. What might save you is, in case you know the graph of y equal x squared. Y equal x squared looks like this. I only meant to really hit at one point on their x-axis. But it's at 0, and it goes up and up and up and up and up forever. And if you don't like that side, the left side starts at 0 and goes up and up and up and up forever. The range of, not y, we called it the f function. I called it f of x equal x squared. The range of the f function is all real numbers. R for range. The range for the f function is all real numbers. Not the friendliest of problems. Now, let's look at another one. Okay, how about h of x is equal to the square root of 2x minus 5. Okay. Now, we know that when you take square roots, when you take the square root of something, either you get 0 or more. This equals 0 or more. Okay, you can take the square root and get a negative number. You cannot take the square root of something and get a negative number. So the question is, fine, every time you take h of something, you'll get 0 or more. Can you get any number more? Okay, so if k is greater than or equal to 0, can you get k? Okay, if k is greater than or equal to 0, can h of something equal k? That's what we want to know. Can you take h of something and get k? Well, what you need to realize, for example, the square root of 3 squared, that is the square root of 9, is 3. It's the numbers that we were squaring. The square root of 5 squared, that is the square root of 25, is 5. This is asking, what times itself gives us 5 squared? For example, the square root of 16 is asking, what times itself is 16? And the answer is 4. But if I write it this way, that is 16. This is asking, what times itself equals 4 squared? Well, 4. 4 times itself equals 4 squared. Just like 4 times itself equals 16. The square root of k squared is equal to k. Okay, so can I take h of something and get k back? Well, sure. H of k squared. That is, if this was k squared, well, I take this back. That's not true. If this was k squared, if 2x minus 5 was k squared, then h of k squared, that's not true. That's not true. If 2x minus 5 equals k squared, then the square root of this, 2x minus 5, will equal to k. Okay, so now I just need to find out what h is. But like this line says, 2x minus 5 must be k squared. Solve it. Bring the 5 over. So then 2x must be k squared plus 5. Divide by 2. And then we have our x value. Just give me a moment, please. Then we have our x value. The 2's cancel. X should be k squared plus 5 over 2. Let's see if this isn't working out. I claim if I take h of that value, I will get back k. I want to know if k is positive, can I take h of something to get k? Well, h of k squared plus 5 over 2. Well, what does h do to what's in the brackets? It doubles it, then it takes away 5. Then it takes the square root. So I'm going to take what's inside the brackets. I'm going to denote that I'm doubling it and taking away 5. And then I'll take away the square root. Well, the doubling kills off that 2 in the bottom, so I'm left with k squared plus 5 minus 5 underneath the square root sign. But the 5's cancel, so I have the square root of k squared, which is k. That is, I found h of something that gave me back k. K is any number. Okay, no matter what k is, I can find out what x should be so that h of that x value is k. Now, we need to take into account one last thing. For any k, is this defined? The answer is yes. It's never There's no 0 in the bottom ever, and nothing underneath the square root sign is negative. So the answer here is, the final answer is, the range of the h function is all real numbers. I can get h to be any number I want. I can get h to be 20. And we are going to do that right here. I can find h is something that gives me 20. If h is something equals k, then this is our recipe to find the x value. If I want 20, so k is 20. X is 20 squared plus 5 over 2. K is 20. I want to find h is something that equals 20. So I'm claiming that here it is. 20 squared is 400 plus 5 over 2. It's 405 over 2. I claim that h of 405 over 2 is 20. Let's see if I'm right. Well, h of any number. You take that number, you multiply it by 2, you take away 5, and then you take the square root. The 2's cancel out, so it's the square root of 405 minus 5. But 405 minus 5 is 400. Oh my goodness. The square root of 400 is 20. I can find the x value, so f of that x value can be any number I want. Okay, you have to do things in general. You have to say, well, can h equal k? And then work backwards to say, here's that x value. Here's that x value that makes h of that x value the number I want. Alright, folks, I don't make this stuff up. I don't make up these problems, nor do I make up the topics that your instructor wants you to know. But here it is. Let's try one more. Suppose you have x squared minus 9 underneath the square root sign, and that's capital G of x. Okay. Now, I know one thing. Whether I can get every number, I will only get 0 or more. I will only get 0 or more. Okay? When you take the square root of something, no matter what number I give you, when you square it and take away 9, you get a number. And if it makes sense, then you're going to get 0 or more. You can never take the square root sign and get negative. Sure, you can take the square root sign and not get 0 or more, but then it won't make sense. For example, g of 1 makes no sense. 1 squared is 1 minus 9. That's the square root of negative 8. That makes no sense. Okay, 1 is not in the domain. But if we only consider values that are in the domain, and you take g of all of them, you will get 0 or more. You may not be able to get every number more than 0. You may not be able to. Maybe you can get 17. But whatever you do get will be 0 or more. The question is, can you get any number 0 or more? Can you get 0? Well, the only way you get 0 is if this is 0. The square root of 0 is 0. And for example, if x is 3 or negative 3, g of 3 is 3 squared, which is 9, minus 9 is 0. The square root of 0 is 0. If you plugged in negative 3 instead, negative 3 squared is 9, minus 9 is 0, and the square root is 0, 0. So you can get 0. That is, 0 is in the range. Can you get more? Any number more than 0. Can you get 7 and 17 and the square root of 11 and 9.3 and 9 over 7 and 9 over 81 and 0.000123? Can you get all those numbers? Well, you need to find the x value. If it is true, you need to find the x value so that g of that x value is the number you want. So you do it in general. You let k be greater than 0. We already showed it can be 0. G of 3 is 0. So can we get any number more? Well, let's see. Can the square root of x squared minus 9 equal any number k? Well, let's solve this for x. Let's square both sides. So x squared minus 9 would have to be k squared. After all, the square root of k squared is k. Add 9 to both sides. Add 9 to both sides. So x squared must be 9 plus k squared. So then x can equal to the square root, plus or minus actually, the square root of 9 plus k squared. Now, let's just talk for a moment. Suppose we got x equal to the square root of 9 minus k. Well, remember, k is 0 or more. Well then, k can then only be between 0 and 9. Because the x that you're looking for has to make sense. You can't take, for example, g of 3 over 0. We're finding the x value that goes in there. It has to make sense. You can't take g of the square root of negative 2. So if this was underneath the square root sign, x can only, what's underneath the square root sign has to be greater than or equal to 0. Bring the k to the other side, and then you learn that 9 must be greater than or equal to k. There's only one reason 9 is bigger than k, and that's because k is smaller than 9. And you have a constraint that k is greater than or equal to 0. Okay, so you can only have k being between 0 and 9. Okay, we said that. We mentioned it. Let's go back to our example. Let's go back to our example. This will always be positive. Why? Because k squared is always bigger than 0. And if you add 9 to it, bigger than or equal to 0, if you add 9, then 9 plus k squared will always be 9 or more. So what's underneath the square root sign is always positive. Can be any value you want. There is your recipe. That's the x value that will get you back any k you want. Now, this you don't need to do, but I want to show you that it is working. Pick a value for k. Let k be 10. Well then, x, just pretty much copying down there, x should equal to either plus or minus. We have two answers of 9 plus 10 squared. Well, 10 squared is 100, plus 9, 109. X can equal plus the square root of 109 or minus the square root of 109. Let's see if this is working. What is g of those values? Well, what is g? I'm on the top here now. What does g do to what's in the brackets? It squares it, then it takes away 9. Then it takes the square root. Well, if I square either one of those numbers, I get 109. Because the square root of 109 times itself, that is squared, is 109. And if they're both positive, I get positive. They're both negative. A negative times a negative is positive. I get 109 minus 9 square root. Well, 109 minus 9 is 100. Oh my goodness. The square root of 100 is just what I wanted, k. I found f of more than one number that gives me k. I can find, I meant to say g. I can find g of a number that gives you any positive value. Here is my recipe. Here is my recipe. Let x be one of those two numbers. Okay. Again, if it turned out that x was equal to plus or minus 9 over k squared, well then k couldn't equal 0, because 9 over 0 is undefined. I can't take g of 9 over 0 and get back, well k is 0 then, and get back 0. Because g of I don't know isn't 0. G of I don't know equals nonsense. Okay. The last thing I want to do is talk about ranges over a given interval. Suppose I tell you that f of x is some line, 3x minus 1, but x can only go in between 2 and 5. Now, since the slope is not 0, even if you don't know how a positive slope looks or a negative slope looks, you have some kind of a line, and it goes from 2 to 5. That is, you're only keeping this portion of the line. Now, either the line went like that, or maybe a positive slope. Let me draw it over here. Or maybe a positive slope goes this way, which is not true, but let's say for argument's sake, 2 to 5. That is, you're only to keep this portion of the graph. But you know what? The y values are all in between here. The y values are all in between here. This x value corresponds to that point, or corresponds to that y value. This x value corresponds to that y value. 5 corresponds to this value up here. 2 corresponds here. Even if I have it backwards, 2 corresponds there, 5 corresponds there. For this x value, we get back that y value. For the x value here, we get back that y value. In fact, we get back all of these y values. That is, why not find out what f for 2 is, and find out what f for 5 is, and say we get all values in between. What does f do to what's in the bracket? It doubles it and takes away 1. I meant to say it triples it and takes away 1. 6 minus 1 is 5. F for 5, I multiply what's in the brackets by 3, and I take away 1. I get 14 minus 1, or 13. And then I say that the range of the f function is, now we're talking about y values, they're in between 5 and 13. And they can equal. I mean, if you want, you could have drawn it perfectly. But there's no point in that. I want you to think about why you just have to look at the endpoints. Why do you have to just look at the endpoints? Think, maybe it'll take you 10 minutes or 1 minute. Maybe you already got it. Maybe it'll take you 2 hours. But if you want to understand this, you have to think about why it's going to be in between f of the left endpoint and f of the right endpoint. The answer is going to be in between f of 2 and f of 5. It's always going to be that for a line where the number in front of x is not 0. For example, if I told you that g of x is equal to negative 7x plus 1, and x goes in between, I don't know, 3 and 10. X goes in between 3 and 10. So you calculate g of 3. That is, you multiply negative 7 by 3 and add 1. Negative 21 plus 1 is negative 20. And you compute g of 10, which is negative 7 times 10, which is negative 70, plus 1 is negative 69. The range goes between those two numbers. And those are y values. Y is equal to g of a number. Y is equal to g of a number. So the range for the g function is y is in between, and the left number should be smaller. Negative 69 to negative 20. And of course, the right number should be larger. And there's your range. How about we do one more? Okay. With the range, one has to think. To be honest, if these problems are really, really too hard for you, if you understand everything else, then spend more time on this. If you're not understanding everything else, you probably have a better chance of learning the other stuff better than you will ever understand this. It's really a function of how much time you have. So if you're told that h of x is equal to x squared plus 1, and I tell you x goes between 0 and 5. Well, all these numbers, none of these numbers are negative. When you square, I want to think if this is true. Excuse me a moment. A quarter is less than a half, which is less than 3/4. And when I square them, okay. When you square larger numbers, you get larger answers. And if you add 1, well, if you have two numbers and one is smaller than the other, and you add 1 to each of them, the smaller number plus 1 will be smaller than the larger number plus 1. That is, if 7 is less than 10, if I add 1 to both sides, then 8 is less than 11. That will always be true. Well, if you're squaring numbers between 0 and 5, 0 is going to give you the least, and 5 is going to give you the most. H of 0 is 0 squared plus 1, or 0 plus 1, which is 1. And h of 5 is 5 squared plus 1, which is 25 plus 1, or 26. Now, you really should know what x squared looks like. It goes like this. But you only want to keep the portion between 0, that is x squared. And when I add 1 to it, every point goes 1 higher. Every point is 1 higher. Okay. Now, we're going from 0 to 5. That is, I don't want this portion of the graph, and I don't want that portion of the graph. I only want the portion of the graph whose x values go from 0 to 5. Well, whatever values they're taking on, they're not skipping any. That is, they're going to be everything in between here. We're not skipping any y value. Let me draw. Let's let 5 be a bit further out here. I'm not skipping any y value. What on earth am I saying? Well, if this is 14 and this is 16, I'm going to be 15, I'm going to be 14.3, 15.8. That is, the graph is not doing things like, well, let's skip that value and skip here. Well, then you won't be this number right there. You won't be that number there. But that's not true. These points are filled in. They are filled in. So basically, you're going to get all of these y values. The lowest one corresponds to g of 0, h of 0, which is 1, and the largest point corresponds to h of 5, which is perfect, 26. That is, the range of the h value is y is in between 0, I'm going to change that, between 1 and 26. The range of the h function is it's in between 1 and 26. Okay, do lots of these, think it through, and then you can do it. Okay, good luck with your domain and ranges.